Welcome to myprojectbazaar.com. Now we are going to discuss about the project Seasonal Crops Disease Prediction and Classification using Deep Convolutional Encoder Network. Now we are going to discuss about the abstract of the process. The process is proposed and implemented in the digital image processing technique using the OpenCV for separating the disease part of the crop from the images from the crop regions, which means the disease part should be extracted from the crop and then the other backgrounds will be eliminated. The major steps like feature extraction and classification is done for the crop images to classify whether the input image is affected by the disease or not. This proposed technique can facilitate the process of the detection of diseases in the crop. The system allows to follow a particular pattern of capturing the images of plants so that it will trace the analyze and quickly. This process will ultimately contribute in semi-automation system of the agricultural process, which is faster and will make the farmers to cultivate more in less amount of time. Even though if the process is working fine, in the final stage of the process we are going to implement the performance parameters by using the accuracy to estimate whether the classifier is working fine or not. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. The working flow consists of the modules such as input, pre-process, segmentation, feature extraction, classification, and finally performance estimation. At first, the input image is taken from the dataset. The dataset consists of both the images of affected and non-affected crops. After getting the image from the dataset, we just move on to the second step of the process, that is the pre-processing. In this pre-processing step, we are going to use the image resize to resize the image into an aspect size of 256x256. Then after getting the image resized, we just move on to the third stage of the project, that is the segmentation. In this segmentation step, we are going to apply the algorithm named as the k-means clustering algorithm to segregate the affected portion from the background regions. Once the k-means is applied, the affected portions will be extracted separately. After done the segmentation, we just move to the fourth stage of the project, that is the feature extraction. So in this feature extraction, we are going to apply the two kinds of features, that is the LBP and HOG. By using these two features, we are extracting the features like color based features and then the pattern based features. The color based features is taken by using the histogram of oriented gradients, that is the HOG. Then the pattern based feature is extracted by means of the LBP, that is the local binary pattern. After that, simultaneously we are going to apply the SVM for this feature extraction and then doing the classification. In this classification steps, we are applying the support vector machine classifier. Then the predicted result should be shown as whether the input crop is affected by the diseases or not. After done all the classification, we just move on to the final stage of the project, that is the performance estimation. In this performance estimation, we have to find out the performance like accuracy, sensitivity, specificity, and finally error rate. So we have to find out these four parameters. By using these four parameters, we can justify our processes efficient or not. Now we are going to discuss about the running procedure of the project. First of all, open the Python Spider 3.7. After that, change the current directory. Then click this button to execute the process. Now the tick enter will be open. In that tick enter, you have to select the image. In that data set, there are a lot of images in the data set. You have to select any one image from the data set. After the selection of the image from the data set, the corresponding result will be displayed in the consoles. Now I am going to explain the results one by one. Now this is the image which I have taken from the data set. After collection of the image from the dataset, the original image is displayed in the console. Then we just move on to the second stage, that is the pre-processing and then segmentation. The pre-processing image having the image resize, you can see the difference between the input and then the pre-processed image, as well as the mask will be generated in the k-means clustering algorithm. This is the mask image of the k-means clustering, hence you can see the difference between the input and output. Hence the mask image consists of the index value alone. After the marks based segmentation, we just move on to the clustered image. Now this is the image which is the clustered image. You can see the difference in the index and the clustered regions. The clustered image shows the foreground regions. The background will be eliminated, hence that is represented in the black color. After the extraction of the foreground and the background, we have to extract the feature from the image. The feature values are represented here. This is the pixel values which is extracted as a features from the image. After the extraction of the features, we just move to the this is also a kind of a feature extraction. Now the feature values are represented here. Similar to that, the feature images is represented here. Once the LBP feature is applied, we are going to done the HOG feature extraction. Now from the input image, the HOG features will be extracted. The HOG images will be looking like this. LBP image will be looking like this. Then HOG features will be looking like this. After that, similar to the LBP, we are going to extract the features from the HOG also. This is the features of the HOG. After extracting the LBP and the HOG features, we are directly go for the classification stage. In this classification stage, we have to identify the disease as well as the disease type. Now, the identified disease type is 1. The corresponding name of the disease type 1 is bacterial affect. So we are just found out the input having the disease of bacterial affect. Now finally the performance estimation. In this performance estimation, the primary performance is the classification performance like accuracy. So we have achieved the accuracy of 80% by using the support vector machine classifier. The performance chart will be shown like this for precision, recall and F-score. Finally, the confusion matrix of that particular performance will be shown like this. This represents the true positive, true negative, false positive and false negative. Thanks for watching this video.